Okay, so we're doing repeated games, which are a little different, and there's a little bit more math involved into them. Again, there's not anything really new here, but it's just more to keep track of. So I'm going to do a couple examples using the game that's up in the corner here with these specific numbers. You should compare and contrast this to what the book's doing. The book uses a different set of specific numbers, and hopefully that will help you see, what is it about the numbers that's happening versus what is it about the procedure that's happening. The book's numbers are kind of specific in a way that leads to some interesting outcomes. Mine will also lead to some, sort of weird outcomes or interesting outcomes. I guess they're not weird, but so I'm going to do this game first. Talk about Grim Trigger against Grim Trigger, or whether or not the threat of a Grim Trigger player is enough to keep someone on a cooperating path. And keep this in mind as we do all of these. We're always thinking about repeated games as a potential solution to the prisoner's dilemma problem. So we're always going to try to evaluate them in terms of, will a player, because of the threat of the other player playing Grim Trigger or Tit for Tat or something like that, will a player continue to cooperate even though they have a dominant strategy of defecting, which we see in the one-shot prisoner's dilemma. The only Nash equilibrium is defect. But here, could it be that it is rational for them to cooperate because of the threat that's coming from the other player, the threat of punishment? Okay, so I'm going to start drawing on this. So I've got a game here that is a little different than Grim Trigger games that we've had before, but not a lot. Sorry about the noise as I drag things around here. And what we want to do to ask whether someone will cooperate or not is we want to compare. What do they get if they keep cooperating versus what do they get if they defect? And this is an infinite game, so the payoffs go off forever and ever and ever. And the interesting way that your book does this is it actually talks about changes from cooperation. So first off, if a player just cooperates, if they're playing somebody who's Grim Trigger and they cooperate forever, we will stay right up here. We'll get 4s forever and ever and ever. Remember that Grim Trigger is start with cooperation and only defect if the other player defects. But then, of course, they defect forever. So in the cooperation mode, if a player cooperates, say P1 is playing P2 and P2 is a Grim Trigger player, if P1 cooperates, they will get 4. As long as they keep cooperating, they will keep getting 4. So then our next situation is to ask about, what happens if they defect? So if they defect, and I'm just naming rounds here, round 3, round 4, round 5, whatever, what will they get in terms of differences? So this is a unique thing that your book does. This is actually not the way I've done this in the past, but it does actually simplify some of the math to do it this way, which is talk about what is the difference that they get. So we're comparing everything to this 4-4. So if they defect in the first round, the Grim Trigger player, remember, in the first round starts playing Cooperate, or in any round is playing Cooperate until a defection has happened. So the first defection, if player 1 does that, they would be here. We would be in this situation, which for them means they get 1 more than they would if they had cooperated, a 5 versus a 4. That 1 is the difference between those two. In round 2, and every round after that, player 2, who is our Grim Trigger player, will be defecting. Player 1 has no incentive to cooperate ever again. Player 2, it's truly Grim Trigger. They will defect forever no matter what player 1 does from this point on. So player 1's best bet is to just keep defecting. They will keep getting 2s, but that 2 is 2 less than they would have gotten if they had stayed cooperating. So it's -2, and it just goes on forever. The rest of the game, they will get payoffs of 2, which are 2 less than when they cooperate. So the way to think about this is there's some benefit to defecting, an initial early benefit, the +1, and then there's some cost to defecting, and that's the continued loss, right? This continued lower payoff after the defection. You should be able to see here, sort of, if you just intuitively look at it, the gain is +1, the loss is -2 forever, in many, many rounds repeated forever. That should hint at us that it would be really weird for somebody to defect with these payoffs. What we're going to end up solving for is, what would the rate of return have to be? Rate of return is sort of like, what, how fast does this payoff grow? Or if you think about it in another way, if there's a really, really high rate of return, that means players should really value current payoffs. If the rate of return were, for example, 100%, that would imply that a payoff, again, tends to be thought of in monetary terms. A payoff of $10 today is worth the same as $20 tomorrow, or in the next period. So this, you're getting a little bit today and giving up a lot in the future. That's going to sort of imply to us that somebody would only do this if the rate of return is really, really high, if the current payoff of 1 is worth a lot. You can also think of rate of return as inversely related to patience. If you have a really, really high rate of return, then players will be very impatient. They will want things now more than they want things in the future. But so this stream of payoffs, right, is, again, it's the difference from the cooperate outcome. The other way of doing this is to write out, just a bunch of 4s forever and then compare that to a 5 followed by a bunch of 2s, and that's a little bit more math intensive. So this, looking at the difference, already accounts for what is changing from if they were to cooperate continually. And then we just sort of set up, are the costs greater than the benefits, or the benefits greater than the costs? So you want to be careful with this. You want to think about, am I going to try to explain when they will or will not defect? I tend to go with when will they defect, although you can go either way. It does not matter. Either one works. So for example, it'll just be an inequality. So for example, they will defect if, so they get 1 in the first period, and we don't have to do any discounting of that because it's in the current period. So that's the benefit from defection. And if that's greater than 2, and then what we're doing here is discounting these future sums. So the loss of 2, right? So this is benefits on this side and costs on this side. The first loss of 2 happens 1 period in the future, so we need to discount it because it's happening in the future. The second loss of 2 happens 2 periods in the future. That's why it's being discounted twice. The third loss of 2 happens 3 periods in the future. That's the 3 there. And this goes on indefinitely, right? Well, there's a nice little shortcut for infinite series like that. If you have a constant term, in this case 2, that is divided by 1 plus r, and then divided by 1 plus r squared, and 1 plus r to the third, and so on and so forth, that we can just rewrite as 1, that goes down, and limit is equal to 2 over r. This is true if r, for any r that is a positive number. And so we've got 1 greater than 2 over r. We can solve for that. Very easy. R greater than 2. If the rate of return, r, is greater than 200%, remember that these are percentage rates, so 2 is actually 200%. If we had gotten a number like 0.5, that would have been 50%. If the rate of return is greater than 200%, this player will defect against a Grim Trigger player. Of course, the opposite is true too, and you could have easily done this by just flipping the inequality. If you want to find out when they will not defect, right? Let me just do it over it in color. They will not defect if you do that. And so that gives you, if R is less than 200%, this player will not defect against a Grim Trigger player. And you can see you can probably guess at the inequality, right? If it's exactly equal to 200%, this player would be indifferent. They might defect, they might not. They would get the same payoff either way. Now, 200% is an incredibly high rate of return, which makes sense. These payoffs are really skewed in favor of cooperation. Again, giving up 2 forever and ever in favor of just getting an immediate boost of 1 would not be something you would be likely to do unless you were incredibly impatient and really valued the future. Really valued the current over the future. Really will, like, this is the same idea that this player would be willing to borrow money at a 200% interest rate. It's really extreme, but if you tweak these numbers, if you play around with them, you should be able to get something maybe a little more realistic. And we'll look at the general form in the next video set. But I do want to talk about the tit for tat option here as well. So Grim Trigger is an incredibly strong punishment. Grim Trigger is, once you've defected once, if I'm a Grim Trigger player, I defect forever and ever and ever. It's not great for either player. If you think about player two's perspective here, they got taken advantage of once, and now we're in this unhappy low payoff of defect forever and ever and ever. And so we might be curious about what about a less severe punishment like tit for tat? So let's look at tit for tat. Tit for tat gets a little more complicated because there are 2 ways a player might defect, or might not, I don't know why I put air quotes around that, I don't need air quotes, not cooperate versus tit for tat. They could just defect forever. They could just, defect, and then the other person will defect, but then they just keep defecting and defecting and defecting. That's the same math that we did against the Grim Trigger. So in this game, only makes sense if R is greater than 2, or if the rate is greater than 200%. That's the same as Grim Trigger, right? Like if I'm playing a tit for tat player, and I defect in the first round, they would have cooperated in the first round because tit for tat starts out cooperating, but then they'll defect in the second round. What do I do in the second round? If I defect in the second round, they'll defect in the third round. So if I just defect forever, they'll keep defecting forever after that first round, and that looks the same as the Grim Trigger. But I could also defect just once. Tit for tat allows the possibility of sort of redemption here. It allows me the capability of defecting and then watching to see, defecting and then cooperating again so that the other player resets and they come back to cooperation. This is a little weird, and in practice, what this player would actually do would not defect just once. They would defect every other turn. They would be going through and they would be sort of tricking the other player into defecting and then cooperating once the other player starts cooperating again, then defecting. It would be, I've called it like a little trickster strategy before. What would that look like? Let's sort of take a look at this using the same, like this. In that first round, when they defect, they get +1. They get the 5 instead of the 4. And then in the next round, the tit for tat player is defecting, but player one's going to cooperate to get them back on board. Well, what's that mean? That means they get 1, which is 3 less than they could have gotten in the cooperation situation. But then the tit for tat player is going to cooperate in the next round because player 1 has just cooperated in round 2. So in round 3, the tit for tat player will cooperate. Player 1 can screw them over again, essentially, could defect again, get that +1 and -3, and it just goes on forever. You could do a complicated sum for this, but in practice, what this boils down to is all that matters for that is just looking at one iteration of it. If it makes sense to do it once, it will make sense to do it continually. If it doesn't make sense to do it continually, it won't make sense to do it once. All we have to look at is that comparison of, the boost of 1 versus the loss of 3. This is a little different than, you might think that loss of 3 means this is obviously a bad idea. But compared to the Grim Trigger, which was a loss of 2 permanently each and every round, this is a loss of 3 just for 1 round. Right? When you defect once, you're only punished for 1 round in tit for tat if you cooperate again. So what does this look like? Let's use the same they will defect if idea. They will defect if 1, the benefit to defecting is greater than the cost, which is 3 over 1 plus r, discounted once because it's 1 period in the future. And note that I'm, not putting the negatives on my benefits side or on my cost side, right? Because the idea is that I'm talking about like the cost implies the negative there. So this is quite easy math, right? This is just 1 plus r is greater than 3. With these numbers, it works out to be the exact same. It will not always, right? But in fact, let's do a side example where we change things a little bit to make it, a little bit more realistic or a little less the same as, not more realistic, but less the same as the previous example. Let's take these numbers, and so I'm going to redo this example. I'm going to erase the stuff on the slide and change the game. But so before I do that, I just want to wrap up with this. We get the R, if R is greater than 200%, defecting is worth it. And if it's less than 200%, it's not worth it. But let's do that other example. So let me erase this and modify the game a little bit. I'm going to just take this 1 and make it a 0. That's all I need to do to really tweak this and keep this as our tit for tat player. Now, when we look at what do we get when we defect just once? Well, we get +1, 5 versus 4. And then if we are going to go back to cooperating in the next round, we lose 4. We get 0 versus the 4. So it's a -4, and it would just go, cycle back and forth. So they will defect if 1 is greater than 4 over 1 plus r, right? Which 1 plus r is greater than 4, r is greater than 3. The only thing you have to keep in mind with tit for tat is we had 2 possible ways they might defect. The way where they defect forever, which the tweak I made doesn't change that. It's still only if the rate is greater than 200%, or 2%, 200%, yeah, it was greater than 2, which is greater than 200%. And they'll defect in this way if the rate's greater than 300%, or r greater than 3. So the question is, what about if the interest rate is 250%? What happens? So what we would say is, if the interest rate was 250%, tit for tat would not be strong enough to keep someone cooperating. They wouldn't defect in the way that's shown on this slide, but they would defect in the way that was similar to the Grim Trigger defection, where they just defect forever and ever and ever. So it's whichever is the easier bar to cross is the one that matters. As another way of showing that, let's make this, instead of 1, let's make it 1.5. Then it's +1 and then minus 2.5. Again, comparing to that 4. What do they get? They get +1 when they defect first, 5 versus 4. And then when they cooperate to reset, they lose 2.5. That would be 1 greater than 2.5 over 1 plus r. So that one, if the payoffs are in that way, then they any interest rate greater than 150% means they will defect in this manner, or they will find it advantageous to defect in this manner. So if the interest rate were, say, 175%, they would defect in this way. They would not be willing to defect permanently, but they would be willing to do 1 period of defection, 1 period of cooperation, 1 period of defection, 1 period of cooperation, and so on. So it's always keeping in mind, are you solving for where they will or will not defect, which way your inequalities are going? And you can always sort of review that by thinking like, higher interest rates will always make defection more likely. So if you've got R greater than 150, that's got to be talking about when they will defect. Because if you think about like an infinitely high interest rate, that causes people to defect completely. So think, keep the intuition in mind. But whatever the easiest bar is to cross. So in this case, if you do this, the 2 ways you can defect in tit for tat, permanent defection is only makes sense if the rate is greater than 200%. The alternating defection, it makes sense if the rate is greater than 150%. So any rate greater than 150% means you won't get cooperation. You'll just get this version of it up to 200%. And then over 200%, there's 2 ways that are better than cooperating. But what we're concerned about, and on the other hand, the side that we're interested in is, hey, look, if the interest rate is not crazy high in this payoff, this works. This gets players to cooperate, which is a really nice outcome that you don't get in the one-off. This threat of punishment serves as a way to commit players. It's a strategic move on the part of player 2, really, of threatening punishment in the tit for tat method that makes player 1 willing to cooperate. And so if they both play tit for tat, or if they both play Grim Trigger, looking at our previous slide, they'll get a cooperation outcome, which is better, which is an improvement over the one-shot prisoner's dilemma.